at parabolas, this entire chapter is based on conic sections. So what is a conic section? Well, it is a curve obtained as the intersection of the surface of a cone with a plane. So we have a cone here, and if the plane intersects the cone horizontally, the curve we get is a circle. Now, if the plane cuts the cone diagonally, but it doesn't go through the base of the cone, the curve it makes is an ellipse. Now, if the plane intersects the cone diagonally, but it goes through the base of the cone, the curve we get is a parabola. And finally, if the plane intersects the cones vertically, the curve we get is a hyperbola. And in this video, we'll be looking at parabolas. Now, looking at the real-life applications of parabolic curves, we have a parabolic mirror. Now, what this does is reflects light, sound, and radio waves to a focus. So, in this diagram that we have here, we can see the waves hitting the parabolic surface and reflecting onto the focus. Now, we can see an example of this in real life, the satellite dish. Now, this works in a similar fashion. When a beam hits the curved dish, it reflects the signal onto the feed horn. So this is the feed horn. And then this passes the signal onto the receiving equipment. Now, if we reverse this process and instead transmit a light, sound, or radio wave from the focal point, this is the effect it would have. Okay? So light emitted from the focus hits the parabolic shape and is then reflected into a relatively narrow beam. And again, looking at real-life examples, we can see the flashlight or car headlights which work in a similar fashion. Now, a parabola, it can be defined as the set of all points that are the same distance from a given point called the focus, this is just a fixed point, and a given line called the directrix, which is just a fixed straight line. Now, this is quite abstract, so it's difficult to understand without a visual. So let's look at this video here explaining and visualizing what this definition of a parabola means. So what we have here is a focus, and this is just a fixed point. This is the directrix, which is just a fixed straight line. Now, if we have a point P over here, such that the distance between this point P and the focus is the same distance as between this point P and the directrix are the same. So you can see the distances here are the same. Now, if I move this point P around with the condition that the distance between the focus and the directrix remains the same, you can see the path it shapes out. If I just pause there, you can see that the distances are remaining the same, and this is the path it's beginning to trace out. And you can see this makes a parabolic shape. So as the point P moves around with the condition that it's the same distance away from the focus and the directrix, you can see the shape it makes is a parabolic shape. So now that we've understood this definition of a parabola, we'll be looking at some key terms on this diagram here for a parabola. So we have here the focus. This line that we have here is called the directrix. This vertical line over here is known as the axis of symmetry. This point here is the vertex, and you can see in our diagram it's the minimum point for this parabola. And then we have this line segment in red, which is what we call the lattice rectum. Now, the lattice rectum is a line segment that goes through the focus, so you can see it goes through the focus and is perpendicular to the axis of symmetry. So you can see the lattice rectum is horizontal, the axis of symmetry is vertical, so they are perpendicular. And you can see that the endpoints of the lattice rectum lie on the parabola. Now, this is the equation of a parabola in general form, which is useful for things like the quadratic formula. However, we can obtain more information if we write the equation of a parabola in standard form. And we have two types. Now, the values of a, h, and k will be the values that will help us determine more information about the parabola, and we'll look at that later on. Now, if we look at the main differences between these two, over here, when we square this bracket, we'll end up with an x squared term, which tells us the graph will have a vertical axis of symmetry. So these are what they would look like. Okay, so this graph opens upwards, this graph opens downwards, but they both have a vertical axis of symmetry. And over here, what we've highlighted in purple, if we square this bracket, we would end up with a y squared term, which tells us there will be a horizontal axis of symmetry. And this is what the two graphs would look like. So this graph opens to the right, and this graph here opens to the left, but they both have a horizontal axis of symmetry. Now, once we know the orientation of the parabola, so whether it's vertical or horizontal, we can use the values of a, h, and k, or a, h, and k, and substitute them to find things like the coordinates for the focus and the vertex, the equations of the axis of symmetry and the directrix, or even the length of the latest rectum. So over here we have a table which summarizes how we can find that information. What we have in blue here relates to the vertical parabola. What we have here in purple relates to the horizontal parabola.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom. The first session is always free. We cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. So if you are interested in a free lesson, click the link in the description below, and send us a message now. Okay, with that said, let's get back to our lesson.
Example 1, we want to write y equals 2x squared minus 12x plus 6 in standard form, and then use this to identify the vertex, axis of symmetry, and the direction of opening of the parabola. So this is the original equation, and what we want to do is to isolate and factorize the variable terms. So I've highlighted the two here. We have an x squared term and an x there. This is our constant. Now, we want the coefficient of x squared to be equal to 1. Over here, the coefficient of x squared is 2. So we'll take a factor of 2 out to give us the following. And you can see within this round bracket, the coefficient of x squared is indeed 1, which means we can now apply the technique of completing the square to this round bracket to give us these square brackets. Okay, and you can see the 2 remains the same, the plus 6, which is the constant, remains the same over here. Now, when we expand this square bracket out by using the distributive property, we get the following. Minus 18 plus the 6 will simplify to minus 12, and you can see that this is in the standard form as required by the question. So now that we have this in standard form, we can find the values of a, h, and k. So we can see that a equals 2, h equals positive 3, and k equals negative 12, which I've written over here. Now remember, the x squared term indicates a vertical axis of symmetry. Now we can find the vertex because it has coordinates h, k. H is 3, k is minus 12, so the coordinates are 3 minus 12. We can find the equation for the axis of symmetry, which has equation x equals h. H is 3, so we can say that x equals 3. Now, since a equals 2, which is greater than 0, therefore the parabola opens upwards. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now for example 2, we'll be graphing each of these equations which are written in standard form. And we'll begin by graphing part A. So because of this x squared term, we know this is the standard form of the equation we'll use. So we can find the values of a, h, and k when we compare the two. So we can see that a equals negative 3. Both h and k are equal to 0. So we can use this to find the vertex, which has coordinates h, k. So it is 0, 0. So I'll write that down here. And for the equation of the axis of symmetry, we know x equals h. Well, h is 0, so we'll write down x equals 0. Now we can produce a table of values and use these positive integer values for x and substitute them into this equation here to give us these values for y. We can now use this information to finally draw our graph. So we have the vertex with coordinates 0, 0, and we can draw in these points over here. So we have 1 minus 3, 2 minus 12, and 3 minus 27. Now, because the parabola is symmetrical, we can find the other points by reflecting in the line x equals 0. So 1 minus 3 would become minus 1 minus 3. 2 minus 12 would become minus 2 minus 12. And 3 minus 27 will become minus 3 minus 27. And then we can join them up with a smooth curve like so. Now moving on to the equation in part B, we notice that there's also an x squared term here. So we know it will also take the parabolic equation will take the standard form like this. So we can see that a is equal to minus 3, h will be equal to 4, and k will also be equal to 4. So from this we can work out the vertex. So since h is equal to 4 and k is equal to 4, we know that the coordinates for the vertex is 4, 4. Now you should notice that there is actually a similarity between these graphs, and in fact this equation here, part B, or the graph of this equation, will simply be a translation of the graph in part A, which is 4 units to the right and 4 units up. So let's move 4 units to the right and 4 units up, and this will give us the final graph for the equation in part B. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. So for example 3, we're asked to graph a parabola given to us in general form. So this is the equation we're asked to graph. So our first step is to write the equation in this standard form over here. So how do I know this is the standard form that we're looking for? Well, we have a y squared term. This tells us we need to isolate the x term. So here is our original equation, and we'll isolate the x term over here. So we'll begin by adding y squared to both sides to give us the following. And then we'll divide both sides by 2 to give us the following. And you'll notice that the y squared term here has a coefficient of a half. We want the coefficient to be 1. So what we'll do is, these two terms that I've highlighted in blue, we'll take a factor of a half out, and that'll give us the following. So now, in the brackets over here, we can see that y squared has a coefficient of 1. And when we have that, we can now apply the technique of completing the square. So when we do that, we'll end up with what we have here in the square brackets. And now what we can do is multiply out the square brackets using the distributive property to give us the following. So you can see a half multiplied by this bracket squared gives me this term. A half multiplied by minus 4 will give me minus 2, and then the plus 5 is just carried over. When we simplify what we have here on the right hand side, we'll end up with the equation in standard form like so. So now that we have this equation rewritten in standard form, we can use this equation to find the information about the graph. So we can see that a is equal to a half. If we just compare the two, we know that h is equal to a 3, which I've written over here, and k is equal to minus 2, which I've written over here. And from these three values, we can find out all of this information about the parabola. So now, since a is a half and it's more than 0, we know that the direction of opening will be to the right. So it will look something like this, where we have a horizontal axis of symmetry. And then the vertex has coordinates hk, which we can have as 3 minus 2 by simply substituting h equals 3 and k equals minus 2. We know that the equation for the axis of symmetry is y equals k. Well, k is minus 2, so I can rewrite that here. And then for the coordinates of the focus, we can simply substitute for h, a, and k using these values over here. And when we simplify this, we get the coordinates 3.5 and minus 2. The equation of the directrix we can find by substituting values for h and a from here to give us x equals 2.5 when it's simplified. And then the length of the lattice rectum we can find by substituting the value for a, which is a half. And when we do that and simplify it, we get 2 units. Now for step 3, we want to draw the graph of this equation here using the information that we found out by writing the equation in standard form. So from our graph, we know where the vertex is. It's 3 minus 2, so we'll plot that over here. And we know the axis of symmetry has equation y equals -2, which will go over here. And then the focus has coordinates 3.5 and -2, which will go over here. And from there, we can draw a lattice rectum of length 2 units. So if I do that, this will now help us because the endpoints of the lattice rectum lie on the parabola. We have the vertex 3 -2, and from this we can draw in our curve for this equation. And just to complete the question, we also have a directrix with equation x equals 2.5, which goes over here. Now it's your turn to have a go at answering these questions. So pause the video before I reveal the answers. And the answers are the following. Now in example 4, we're asked to write an equation for a parabola with vertex at -2 and -4, and directrix with equation y equals 1. So we'll highlight the vertex and the directrix because this is important information that they've given us. Now let's focus on the directrix. We know that the equation is y equals 1. So this tells us it will be a horizontal line. We know this. So because the directrix is a horizontal line, the parabola will have a vertical axis of symmetry. This tells us the standard form of the equation we're looking for is the following. Now, if we are to use this standard form of the equation for the parabola, we know that the vertex has coordinates hk, and the directrix has this equation over here. So we want to find out the values of a, h, and k using the vertex and the directrix as given over here. So let's look at the vertex firstly. We know the vertex has coordinates -2 and -4. So we can see that h is -2 and k is -4. So let's write that down over here. Now, looking at the equation, we know what the y value here is. Y is equal to 1. This is the equation of the directrix. So we can replace the y with the value of 1 over here. And the k, we know this is -4. So we can substitute for y and k to give us the following. An equation we can solve to find the value of a. Now, we begin this by adding 4 to both sides. These two will cancel and we'll be left with the following. Then we'll multiply both sides by 4a. These two will cancel and we'll be left with the following. And then we'll divide both sides by 20. And then we'll find out a is equal to -1 over 20. Now that we know what a is, h and k is, we can substitute these values into this equation over here. And then this tells us that the equation of the parabola is y equals -1 over 20, brackets, x plus 2, close brackets, all squared, -4. And that completes the question.